So in mechanical properties of solids, what we are going to cover is introduction, what is included in this chapter, and elastic behavior of solids, stress and strain curve, Hooke's law, and stress strain curve, elastic moduli, so different modulus of elasticities. Next, how elastic behavior of materials is used in our day-to-day life. That is what application part, right? Now, so we will go with what we know initially. What is the basic concept which we know? From there, we will try to enter into our chapter, reviewing what we know. So, what we know actually, gases. So, how the gases will be highly compressible, right? Next, low density, and it fills container. And solids, highly slightly compressible. Okay, we cannot compress that easily, whereas this we can push them towards. Of course they are coming into our hands or not, but we can, it is compressible easily. So whereas it is slightly compressible as compared to gases. Next, high density will be there. Here particles are closely apart, closely packed, where here particles will be far apart, and it fills container, and it direct, it will have a certain shape, right? Now those, if we observe, this will be the different kinds of matter which we have, right? So gas molecules will be far apart like this, and liquids will be in between, liquid substances will be in between both of them. So the properties also lies between them. Okay, and solids will be closely packed like this already, which we know it, which the information which we have basic knowledge on this. From here only I wanted to continue. And what is our chapter? Mechanical properties of solids only. That means we are going to discuss about only this third part of it, which is slightly compressible, which will be having high density, and which are rigid, means keeps a certain shape, right? Not like these two materials. Okay, now in this uh, we are going with solids. In solids, how these are packed, how the bonding between them, if we check once, so how it will be, we'll go with that. Right. So if we are going, we are speaking in terms of the molecular forces in between them. Suppose if I take hydrogen oxygen relation, that means water molecule. If I take, so between two water molecules, there is a bonding existing between them, right? So that bonding existing between the water molecules, we are calling it as intermolecular forces. Okay, so which occur between the molecules. The intermolecular forces are the forces which is existing between the molecules. And what about these, the forces existing inside the molecules? These bonds are there, no? There also, these bondings are also responsible due to some forces. So that forces are called intramolecular forces, which are occurring inside the molecule are called intramolecular, which are occurring between the molecules are called intermolecular, right? So intermolecular forces are there, intramolecular forces are there. Two types of forces are existing for any substance if we take in general. Okay, and from here we will continue. Next, microscopic nature of a solid. If we take any solid substance, so previously we have seen in previous diagram, all solid atoms are packed closely. And if that packed closely atoms, see one here, these bondings are there, no, between the atom to atom. So the same bondings I have taken in terms of some spring-like arrangement. That means when we press any of, when any atom is pressed, what happens? It will be moving, but again it comes back to its original form due to that microscopically some forces acts in between them. What are these forces actually? What we call them here, between the atoms, whatever forces are there, those are called intramolecular forces. Here also intramolecular forces exist between them. Those intramolecular forces are responsible, those intramolecular forces are responsible for its movement, it movement and it gaining back to its original shape, right? Now just a minute, I will use some, what we call, some laser pointer I'll use, so that it will be easy for distinguishing. No. So these are the intramolecular forces existing between the atoms, and those I am taking for better understanding what I have taken. I have taken them like a springs. That means if a force is applied, it will go and again comes back to it. That means these intramolecular forces are acting like elastic forces. So what is that elastic and all we will see. So this is what exactly happens in microscopic view inside the solid material. What exactly happens? And we can understand it better by considering some spring-like arrangement in between atoms. Okay. Now we will go further. This exactly we will be able to understand about this diagram exactly further. Now next, further if you see, hmm, right, properties of solids. Properties of solids. If we go, so basically we will be discussing about two properties in case of solids. That is, it's a strength and resistance. Strength means what? How strong it is. How much force it can withstand. And resistance means what? Of course, how it can resist it, its deformation. Suppose if I want to break some solid material, so depending on its strength and resistance, it will depend. That's breaking of the material depends on these two main properties, strength and resistance. Okay. So about these two properties we will go in detail how exactly it will be. Hmm? Right. So if we go further, so these mechanical properties include majorly four properties it will be. So one is elasticity, other one is plasticity, another one is ductility, and the last one is strength. Okay. So these are the mechanical properties which generally we have. Now, so what does elasticity means? As we know, the best example, better example which we will come across is rubber band. Rubber band, we can pull it and automatically it will come back to its, regains back to its original shape, right? So that property which is existing in that rubber band material is called elasticity property, right? That is also one property in mechanical properties. And plasticity is what? If some other material, if we take same, like how we are having a rubber band, similar way, one small thread I have taken in the same fashion, right? Now, so I have a rubber band and the same way I have same like arrangement in the thread. If I pull this, what happens? It will break, right? It will be break. It is breaking up. So such property existing in this material we call it as plasticity. So plasticity is not existing only for plastic materials. Don't think in that way. For all the materials which can break, those can be called as the plastic materials according to our chapter. Now, so that is about elasticity and plasticity. We will go as per definition only, right? Elasticity and plasticity, if we go with them. Now, so those properties if you observe. So elasticity is what? Property to regain its original shape once external force is removed. When we are pulling rubber band, if we leave our pulling force, what happens? It will regain back to its original shape, right? So such property we are calling it as a what? Elasticity, right? Next, in the same way, we can have next property is what? Plasticity. So if it does not regain back to its original shape, then if we are applying force, then if it is changing its shape and if it is not regaining back to its original shape, that we are calling it as plasticity, property of permanent deformation, right? So such properties we are calling it as plasticity. Now next, mm, next one, ductility. Ductility means what? Can someone tell me? This well known to goldsmiths. So which if a material is
Shining nature.
right, so we can what we can do, we can pull them into sheets or we can pull them into thin wires. Such a property of material we call it as ductility, right? Now, so property of being drawn into thin wires. This gold and silver, platinum, those will be made into these thin wires, no? So such materials are having property called ductility. That is also one mechanical property. Next, strength. So how much force it can withstand, that we call it as what? Strength, right? No. So ability to withstand applied stress without failure, we call it as strength. Okay, so how much we apply force, that much if it could hold it, it is not going into this plastic nature. So then we call it as it is having more strength. Okay, some materials will be having more strength, some will be having less strength. That is also one more property in case of mechanical properties. Okay, now what we are going to have next, we have come to know what are the properties a material is having, right? Now, and here one word has come. What is that? Stress. But while explaining, I called it as force only. So stress and force are somewhat related now. Okay, so what exactly stress means? So don't compare with the normal stress which we feel, huh? So in terms of physics we are defining, keep that in mind. Now, so stress we are going to define now. So if we are going to define stress, what exactly is that, we will see now. Now, so what is stress? Stress is what? So we are applying force on some object. So keep in mind, plastic bodies we are not considering here. Only elastic bodies we are considering. Okay. So chalk piece if we take in this chapter, chalk piece also comes under plastic material. That means if I apply force, it will deform. Deform means what? Changing its size or changing its shape. Deformation means what? మనం దాని మీద ఫోర్స్ అప్లై చేస్తే బ్రేక్ అయిపోద్ది. సో డిఫార్మేషన్ ఈజ్ నథింగ్ బట్ చేంజింగ్ ఇట్స్ size or shape. Now, what is stress? I am applying force on some plastic body. On which? On some plastic body I am applying. What happens? It will break. So we cannot apply, means we cannot study this topic. So we are, if we want to study this further topics, we have to take a consideration into elastic bodies only. So what are the elastic bodies? Just like I gave one example of rubber band and all. Not only rubber band, which regains back to its original shape, those are all those are considered as elastic bodies only. Now, how exactly that we will understand clearly. Okay. Now, so first we will go with these definitions. Stress. One more definition will come, strain. So we will understand these clearly and we will go with how elastic bodies will be there under. Now, stress means what? I am applying force on some object. Okay, I am applying force on some object. If it remove that, what happens? It will come back to its original shape, right? If it will come back to its original shape, when it is coming back to its original shape, how much restoring force is acting on it per unit area? That restoring force per unit area we call it as a stress. We'll see. Stress is what? Stress is the restoring force per unit area. We call it as a stress. We will see that. Suppose I have a ball, I am compressing it. Okay. So just like that, stress balls will be there, no? We can smiley symbols will be there. If we can press it easily. So when we are pressing it, what happens? And when we press it and leave, it will again come back to its original shape, right? Again, it will come back to its original shape. So how much that ball is acting force in the reverse direction per unit area, that we call it as a stress. Excuse me. If we keep this definition for all types of stress, same definition will write, but slight change will be there, that we will see clearly. So stress, what we are writing? Restoring force per unit area, but action is equals to reaction from Newton's third law. How much force we apply on it? How much force we apply on it, the same amount of force will be reversed back, right? That is the reason this restoring force is equals to F only we will be writing. Okay, so that is stress definition. Stress is what? Restoring force per unit area. Now, what about unit of this? What we write unit? Force unit is Newton and area unit is meter square. So Newton per meter square is unit of stress. We call it as Newton per meter square, can be called as with another name called Pascal. Okay, Pascal or Newton per meter square is a unit of SI unit of stress. Right? Now, same unit again it comes in next chapter also. Next. Excuse me. Next, types of stress if we see. What are the different types of stress? We have three types of stress. Okay, longitudinal stress. In that longitudinal stress, in detail, if you want to see, tensile stress and compressive stress will be there. Right, both are part of longitudinal stress. Next one is tangential or shearing stress. Keep this in mind. Again, we will be using most of the times if we are speaking about tangential stress, shearing stress only we call generally. Now, tangential or shearing stress. Next, hydraulic stress. Hydraulic stress or volumetric stress also we can call this. I'll write better here. Hydraulic stress or volume stress also we can call. We'll see one by one, we will understand easily. Stress, if you could understand, then remaining parts will be easy. Stress is what we are applying force on some object. When we remove the force, applied force, that object will be acting some force in the reverse direction of applied force, that we call it as restoring force. How much restoring force is acting by the body on unit area, we call it as stress. In that stress, we are having three types: longitudinal, tangential, and hydraulic. We will see one by one. In longitudinal also we have two types. Now, so if we see in that, now, mm, no. So in longitudinal, what we have a restoring force per unit area when the force applied is normal to the cross sectional area of the cylindrical body. Now we won't be having clarity with this. We'll go further and we'll have clarity. You see, right? Suppose I have some object, hmm, and to this object what we have done. So I have attached some block to this mass. Okay, the cylindrical arrangement ఉంది, cylindrical arrangement కి ఏం తీసుకున్నాం, ఒక mass ని attach చేస్తాం. Okay, so when we are attaching some mass to this, what happens, it will try to pull this part downwards, right? So how much it is pulling normally, this on this object, how much it is applying force, this side it is applying the force downwards, and that to the surface this force is acting normally. Keep that in mind. When we are defining stress, we will be taking normal force only. And I have to mention one more thing here. This normal force is there, no? All cases we will be discussing about normal force. Normal force means what? Suppose I have some object like this, and if I am applying force in this way, that such kind of force we call it as a normal force. Okay, normal force means what? To the surface, if we are applying force exactly perpendicular, this particular force we call it as normal force. Normal force can have other name also. Normal force we call it as a thrust. So for better understanding, I am just mentioning this word also. Thrust is nothing but normal force. Thrust is nothing but force only, but that force is acting perpendicular to the surface. Throughout stress topic, we will be taking normal force only. That is the reason I have taken this object, no? This cylindrical arrangement I have taken. That cylindrical arrangement I have attached one block downwards so that it acts exactly normal to this surface. To this surface, it is acting normally, and if I am applying force, automatically some extension will be produced in it, as I am considering a elastic body, right? Now, if I consider an elastic body, if I am applying force on it, so there will be some change in its what in the shape of it along the direction of applied force. Now, only lengthwise it is expanding, right? So lengthwise it is expanding. That's why I am calling it as longitudinal. Okay, longitudinal. So expansion is taking place now. Next what happens? Oh, so this is what. So this much it was there. Okay. So this much it was there. Due to applied force, what happened? It is extended little bit. This part is extension in it. If I cut these wires, what happens? If I cut these wires, what happens? These wires are cut. So what happens? Again, it will regain back to its original shape. Okay, so that is what happening. That means we are holding here somewhere and we are attached something downwards, so that extension produced in it. So if we cut the wires, again it will regain back to its original shape. How much it is regaining back, how much force is applied in this particular direction on this area, that force per area we are calling it as a stress. And in this particular case, whatever stress we are getting, in this particular case, whatever stress we are getting, that we call it as longitudinal stress. Longitudinal means the force is applying along the line, length, change in length if it is taking place, we will consider it as longitudinal. And as I mentioned, two types of stress will be there in longitudinal also, right? So how those will be types of longitudinal stress? If we see, restoring force per unit area only, but it will be acting on lengthwise. Okay, cylinder is stretched by two equal forces applied normal to its cross sectional area. So now, if the two forces are applied equally along the length increases. If expansion is taking place, tensile stress we call compressive. If we are pressing, compressing, then in such case whatever stress we get, compressive stress we call. Okay, before that we have done expansion, no? If we apply force in the compression manner, then we will call it as compressive stress. Okay, but for both of them we will be calling longitudinal only. If we are pulling like this, then L plus delta L will come, change will be there. If I am applying stress, if I am pushing, what happens? Compressive stress will get. Okay, so that is about tensile stress and compressive stress. So the definition is same: force per unit area. How much force we are applying on how much unit area we are applying. Okay, here keep in mind we are not speaking about this change. Okay, so we are not discussing about how much change is produced, how much force we are applying on how much area. If it length increases, then tensile strength. If we are compressing, then compressive stress. Lengthwise we are having a stress called longitudinal stress. If if I am not applying lengthwise, if I change my direction of force, okay, then what kind of stress we will be having? That is shearing stress or tangential stress. So here also restoring force developed due to applied tangential force only. Tangential force means this is a block, I am applying force in this direction. Here it is not changing, only this upper part force is applied. Here only the object is changed its shape. So how much change? Again here the change produced, I am taking delta L only. Previously I also have taken delta L. Here also I am taking delta L. This is a L. On this L length it is applied. Delta L is a change. Here I am not considering about how much change I am getting. Only what I want? Stress I want. Stress means just how much force is applied and how much force is applied on how much uh, area. How much area? This should be again normal force it should be, and tangentially if we apply force, that corresponding stress we are calling it as shearing stress. Okay, again same formula, restoring force per unit area only, but the point of application is changing here. Previously we applied lengthwise, here we are applying tangentially. That's why we are calling it as tangential stress. Same again, restoring force per unit area, F by A only we will get. So what exactly the difference we will come to know in the next topic clearly. Okay. Now, so this is about shearing stress. We are applying force in this direction, restoring force per unit area. We call it as again shearing stress. Further if we go, further if we go, hydraulic stress or volume stress. In this, what happens? We will consider one ball-like arrangement, and we are applying force along all the direction. That means we have taken same stress ball example you take, we are just compressing it, okay, along all the direction. That means total volume we are applying force. So in such a way, if we apply force and leave, it will come back the restoring force. This means this is a original shape. Actually this line is there, no? This is the original shape. Which one? This one is the original shape. Now if this is a original shape, this is the original shape. Now this is what our, after application of force, it has come into these dotted lines. What happens if we remove this? It will go back. So in this case, whatever restoring force acting on unit area, we call it as hydraulic stress, right? So the application of force is changing in each case, but definition is same. How much force is applying on how much area? That is called stress. Depending on the application of force, we are having three types of stresses, right? Now, so now we will go with the how much change is produced in each case. Delta L change was produced in each case. That change, about the change if we speak. Stress means what? Simply you assume that it is nothing but a force, but we will speak about restoring force on unit area. Force only, but we are speaking about on unit area. Now, stress is nothing but, in simple terms, if you want to say, blindly if you want to say, roughly if you want to say, it is nothing but force. Okay. Now, if we go with the next topic, what is strain? As I said, stress and strain, two things we are going to discuss in this. Strain, if we are going with, strain is what? the ratio of change in the configuration to the original configuration. Change, if it is length is changing, change in length by original length. If area is changing, change in area by original area. If volume is changing, change in volume by original volume. Like that we will be taking. General definition I am giving. Change in the configuration to the original configuration, we are calling it as strain. Till now we didn't speak about what is the causing, how much change is causing. We just spoke about how much restoring force is acting and how much area is acting, that is stress. Now here we are going to speak about, if I am applying stress, if we have stress, how much change is there. That change concept we are explaining with the term strain. Here, as we have three types of stresses, we will be having three types of strain also. Okay, so longitudinal stress corresponding to longitudinal strain, shearing stress or tangential stress corresponds to shearing strain, and volumetric stress or hydraulic stress corresponding to hydraulic strain or volumetric strain. Okay, సో అక్కడ చేంజ్ ఎంత వచ్చిందో దాన్ని ఇక్కడ మనం కన్సిడర్ చేసుకుంటాం. చేంజ్ ఇన్ లెంత్ బై ఒరిజినల్ లెంత్ లైక్ దట్. Now, so longitudinal strain is what? If the deforming force produces a change in length alone, only lengthwise if change is taking place, then we will then then we will call it as a longitudinal strain. Okay, then we call it as a longitudinal strain. Now we'll see exactly. Right. So the deformation produced if along length only, then we call it as already longitudinal stress. Longitudinal stress, whichever is giving us a strain, that we call it as a longitudinal strain. Right. Now, for this, if we write, so longitudinal strain is what? Change in length by original length. So we have spoke now already. Change in configuration by original configuration. What is changing length? So change in length by original length, we call it as longitudinal strain. What about shearing strain? Here also we have called deforming force produces change in its shape of the body without changing its volume. Only little bit of change is produced in its shape. That if we speak, there also change produced, we have taken delta L. Okay, delta L by original length, we are calling it as shearing strain. Then we got some angle in the diagram, so that angle we can consider directly. Okay, tan theta, in terms of tan theta we can consider. Tan theta is what? Opposite by adjacent. Opposite is delta L and adjacent is L. In that way theta we can consider. Okay, I will show you the diagram again. Volumetric strain means if deforming force produces change in its volume. So what we can write? Change in configuration is what? Volume. Change in volume by original volume, we call it as volumetric strain. Okay, so change in volume by original volume, we are calling it as volumetric strain. Okay, that is about three types of stress and three types of strain. Now next what we have, looks law we will see. Before going to that, I will show you this strain diagram once. If it is clear, we will go with Hooke's law. Right, here we have no, here we have no, now in this mm, no. So delta L is change in dimension, right? Change in its configuration delta L, and original length is L. So this change in length by original length, change in configuration by original configuration is called our strain. So tangentially we are applying force, in that way we are getting change. That's why this strain we are calling it as tangential or shearing strain, delta L by L. This delta L by can write it as theta. Theta is equals to what? Tan theta is nothing but, tan theta is what? Opposite by adjacent. Opposite is delta L and adjacent is L. Delta L by L also we can write for tangential stress. That is about three types of stress, three types of strain which we are having. Right? I hope it is clear. We will go with the excuse me. We will go with the Hooke's law in the next topic. Okay.